You're all very welcome back today. We're back with the dreaded topic of algebra. Some of you might absolutely love algebra, like I do. Some of you might think God was very nasty one day and thought, a bit bored, probably about the 34th or 35th day, and thought, I'll invent algebra because that'll just screw with people. Ah, dear. I should apologise in advance. I know I yawned last week, and there's a good chance I'll yawn again this week because I am in agony. Played football last night, and I'm so sore. I'm just so sore. Whoever said exercise was a good idea? Anyway, algebra. So what is algebra? As I said, for the love of God, why? Why do we need it? Why in the world does such a horrible thing exist? There's God. White suit as well. Nice, isn't it? So, algebra is a set of rules that make up a language for dealing with numbers and letters together. And why would we do this? Well, the good news is that these rules use a lot of the things we already do, like add, subtract, multiply, and divide. Uh, so if you consider driving your car, right? When you learn to do a car, it's very difficult because you've got an order in which you do things. So put it into gear, right? Check my mirrors, right? What comes next? Oh, get my biting point, my clutch, right? That's good. I'll release my handbrake, check my mirrors again, accelerate, and then I forgot to indicate, all that kind of stuff. So that it all builds up. After a while, once you're practiced in driving for a while, you don't even think about what you're doing. You just kind of do those things as a matter of fact, as an order. Algebra's pretty much the same. I'm going to break all the rules down into small bits, and then we'll practice them, practice them, practice them, and you will start to do them without even really thinking about it, the steps. So, algebra allows us to find the values of things that we wouldn't otherwise be able to work out. And you do use it in your everyday lives. So, if you go into the shop and I tell you, right, I can buy bars of chocolate, right, and they cost £2 in total, but they're all cost exactly the same price. What do they cost, right? You tell me 40p, or you should tell me 40p, but I didn't tell you it was a dividing sum. I didn't tell you what to do with those numbers. I just give you some numbers, and your intuition led you to the fact that you should divide there to get your £2 by 5 to get your 40p. All right, so you do use it every day. You just don't quite use it. So the first some language stuff I'm going through to. Right, a term. This is a piece of the problem that involves a letter, or what we call an unknown. All right, so something like 2x, or 8y, or minus t. These are all terms, okay? And minus t actually stands for minus 1t. A bit like plus t stands for plus 1t. When there's not a number in front, it's just assumed that that number's 1, and you'll come up against this quite an awful lot. Second one, an expression. So an expression is a collection of terms, sometimes with a few numbers. So something like 4x plus y. There's two terms. First one's a term because it has a letter, and the second one's a term because it has a letter. 8y minus 3 is an expression as well. It has a term, it has a number as well, but anything like that is an expression. Even something like t minus 4u plus 16 plus 2v, which looks utterly ridiculously complicated, is an expression. Next one. It's an equation. It's very like an expression. It's just an expression with an equal sign in it. So this allows us to solve it. So something like 2x plus 6, which in the previous page would have been an expression, but that's equal to 8. And that becomes an equation then. 8y plus 2z equals 4. 2t squared minus 2t plus 7 equals 0 is also an equation. Okay, first rule. And what I'll say, I'm not going to go through tons and tons and tons and tons of examples on algebra because I could do them all day. Do them all day and all night, and you'd be sick of looking at me, and etc. etc. And to be perfectly honest, I'm going to show you one of each example, and some of them that are harder, I'll point out whether they're harder, whether they're higher tier, whether they fall in that bracket, or whether they just stick with foundation. All right. So you'll practice loads and loads of these over the next couple of weeks in class, because we're probably going to do algebra the whole way up until Christmas. Yippee, said you. Anyway, first rule. You can add and subtract like terms. So like terms are terms which have exactly the same letter or letters as another term. Let's give an example. Something like x plus x. If I add x and x, I get 2x. And the easiest way to think about this is that the x represents something sitting in front of you. What have I got in front of me? I have a CD. Can you see that, right? That's one CD plus another CD is two CDs. And that's just the way you should think of it. Think of it as some sort of tangible object sitting in front of you. To add them together or subtract them. So one CD plus another CD is two CDs. If it even helps you to think better, think of something beginning with that letter. An X and an X. So an X-Man and another X-Man is two X-Men. 4p plus 6p. 4 people plus 6 people equals 10 people. Quite straightforward. Gets a wee bit harder if I make the terms a squared. So 4a squared minus 2a squared. Well, the a squared is still the same in both cases, so it can be 4 apples, take away 2 apples, is 2 apples still. And even though it looks more complicated than a squared, those things are essentially the same. We can take them away and add them together, just like we would any other terms. What about 7ab plus 2ab minus 4ab? Again, it's the same makeup of letters in it, just one a and one b. We can add and subtract them. So 7 plus 2 gives me 9, take away 4 gives me 5. And that's 5 ABs. So, new fruit called apple bananas. 7 apple bananas plus 2 apple bananas minus 4 apple bananas gives me 5 apple bananas. Okay, but you cannot combine unlike terms. So something like x plus y doesn't equal x, y. It just stays as x plus y because we can't combine them. The two of them aren't the same thing. It's a bit like adding apples and oranges. They would just stay as apples and oranges. We can't add them together. 4p plus 6r does not equal 10pr. It just equals 4 people and 6, I don't know, robins. Why is robin the only thing I can think of beginning with r? It's ridiculous. Because the terms are different. Okay, let's put root 1 into practice. So we're going to simplify 2x plus 2y plus 4x plus 3y. And this is a very common type of question. Okay, it can help if you visually differentiate between the two different terms. So when it looks like it does at the moment, it can be hard to pick out the x terms from the y terms, and especially if I throw another variable in there, a z or whatever, it can be very hard to differentiate. So what to do is you start off with this, and I get some people to draw boxes around the terms. So the x terms, I'm going to put an x box around, right? And as you'll notice, I put a box around both the number and the letter, and also the sign or the value. So you see the one on the right is a plus 4x. The first one just says 2x, and if there's no sign in front of a number, it's just assumed that it's a plus, because you wouldn't say, you know, how much money have you got in your pocket, and you say at 140. You wouldn't say I've plus 140. You just say £1.40, because that's just the way you've kind of been brought up to speak it, if you know what I mean. So it's assumed that it's a plus. Similarly with the two y's, I'm going to put a blue circle around it. So the y terms have got a plus 2y and have a plus 3y. And when we come to add them together, we'll start off by adding together just our x terms. So 2x plus 4x, and that gives us 6x. And if we do the same with the y terms, we get plus 2y plus 3y gives us 5y. And the total answer to that is just 6x plus 5y. And those questions will always be stated as simplify, because you can't solve them. When we come to solve equations later, this bit will slightly confuse you because you're looking for the equal sign. Remember that this is just an expression, it doesn't have an equal sign, we can't solve it, but we can group those things together. Okay. Remember, you should include signs with terms. Each term should have a sign, number, letter, like there, sign, number, letter, sign, number, letter. Don't group them number, letter, sign. Sign, number, letter. Saturday Night Live, if you want. And if there's no sign at the start, it's assumed to be a plus. Just like there. Let's example something else. Something that's a bit harder. And we'll probably only come up in a higher tier paper. So if you don't kind of get it, then don't worry about it if you're in foundation. If you're higher tier, do worry about it. Okay, so simplify 2xy plus 2yx plus 4x plus 3y. Now, in first appearance, it appears like there are no like terms. But there are. If you think about it, 4 times 6 is the same as 6 times 4. Okay, and 2xy means 2 multiplied by x multiplied by y. 2yx means 2 multiplied by y multiplied by x. Multiplication is a thing called commutative. It doesn't matter what order you multiply them in. Okay, if you multiply 4 by 6, you get the same result as 6 by 4. If you multiply x by y, it's the same as y times x. So those terms are actually the same. xy is exactly the same as yx. We can group xy and yx together. 2yx is the same as 2xy. So therefore, we get 2xy plus 2yx would give us 4xy plus 4x plus, ooh, that should be 3y at the end. So bad, my writing. I should change that for my notes for next year, but that should be 3y. We can't combine the xy's with the x's or the y's because they're not made up of the same letters. Okay? Bad, 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 bad. The way we generally get around this rule is that when we're writing these equations, we usually put the letters in alphabetical order. And that saves us getting into these kind of problems in the first place. Even harder example. I've got 2x squared plus x squared minus x. Right. Even though it looks like the x squared and the x are the same thing, they're not. They're different makeup of terms. There's not the same amount of x's in an x squared as there is in an x. So even though x squared and x look like the same term, they're different. Therefore, when collecting like terms, we can't mix them. And we can only add together our 2x squared and our x squared to give us plus 3x squared. And our x plus x minus x gives us 0. We call that cancelling each other out. We could write 3x squared plus 0, but ideally, realistically, that's the same as only plus 3x squared. Okay, and that's rule 1. Rule 2. You can multiply terms and numbers together. You need to observe the following parts of the rules. So you can multiply the numbers together first, and observe the idea that a times a is a squared. Put the numbers in alphabetical order and remove the multiplication sign. Mathematicians are very, very lazy. They will use any excuse not to write things down. So like a multiplication sign, and you'll see why. Multiplication sign looks like an X, as you can see there. X gets quite confusing when we're using other letters, so we generally just clump them together. And you'll see what I mean in a second. Following examples. Simplify 3c times 6b. So if we look back at my rules, we're going to multiply the numbers together first. We have 3 multiplied by 6. That gives us 18. When we multiply CB, we'll just get BC. Well, you would get CB to start off with. You just clump them together. But we're going to put them in alphabetical order, so we get BC. So our answer is just 18 BC. Again, we'll practice loads and loads. You'll be sick doing these without doubt on them, and you'll get the feel for it. Simplify 4t times minus 3t. Well, we'll multiply the numbers together first, but 4 times minus 3. Now, if you're struggling with what to do with 4 times minus 3, I've put up a quick flip video on BODMAS, and I've put a quick flip video up on what you do when you multiply positive numbers by minus numbers, and what you do with number line, adding, subtracting positive and minus numbers. Watch that. But what you get when you get 4t times minus 3t, you've got a plus and a minus together. Plus 4 times minus 3, that gives us a minus 12. And like I say, I have a directed number quick flip if you're confused, which you'll see I'll link to on the notes by the side. When we multiply t and t, we get t squared. T times t equals t squared. So the overall answer is going to be minus 12 t squared. And it's important to do the numbers and the letters separately. Don't kind of group them together as one thing. Treat the numbers as numbers and the letters as letters beside you. And observe the directed number quick flip rules. Okay, rule number 3. Dividing uses the same rules as multiplying. Sorry. The key skill in dividing terms is that terms frequently cancel. If we have a term in the top line of a fraction and the same term in the bottom line, they cancel each other out. Remembering that a fraction is just a dividing sum. That line just means the top number divided by the bottom number. And this is the reason. If we have a b in the top and a b in the bottom, b divided by b gives me 1. But like 4 divided by 4 gives you 1, or a million divided by a million gives you 1. Those cancel out, and that b over b just becomes 1. If I look at the example, that looks incredibly difficult and would only be in a higher tier paper. 12xy squared z divided by 4xy. We simplify the numbers first. 12 over 4, or 12 divided by 4 gives me 3. The x term in the top line and the x term in the bottom line cancel. And I'll show you this graphically in a second. There are 2 y terms in the top line, as in a y squared is y times y, and 1 y term in the bottom. So one of the y terms will cancel the bottom with one of the ones in the top. And what you get is this. The 12 over 4 cancel down to 3. Your x and your x cancel out. And one of your y terms, so your y squared term, just becomes a y. Cancels with the y at the bottom. And what we're left with is 3 times y times z. Like I say, it's only a higher tier topic kind of thing that comes up. But that very confusing mess at the top just becomes simply 3yz. I'll do another one because some of these can get a little bit weird. 6 over 36 would do the numbers first. In this one, and that simplifies down as a fraction of 1 over 6. We take our a squared b squared over 6ab cubed. Remember, b cubed is b times b times b. Oh, I should have. Yeah, so the 1 over 6. You could put the 1 on the top line, but we usually just leave it as 1 times that. If you put it in, it wouldn't necessarily be wrong, but you'll get used to just writing it like that. Now, we have two a terms on the top with 1 on the bottom, so one of the a terms cancels with one of the ones in the bottom. With two b terms on the top and 3 in the bottom. So we're going to have the two ones at the top cancel with 2 in the bottom, and we're just left with one b term. And what we're left, as you can see, with is a over 6b. Like that. So again, a mess here at the start, but ends up nice and simply like that. Okay, again, higher tier only. If you're freaking out in your higher tier, it's alright, we will practice loads. I have so many examples of these to do. You'll be doing them in your sleep. You'll be closing your eyes at night and in actual fact, when I did NICATs last year, I taught you this standard, if you know what I mean. If you don't believe me, you look back through your notes when we did algebra in before Christmas, and I did teach you how to divide. I taught you this rule because I knew it would come up again this year for an awful lot of you. And here you are. Hey presto, voila! If you didn't do NICATs, I'm terribly sorry about the oversight and not letting you be in my company last year, but you're here now. And they got it last year, you'll get it this year. You'll be fine. All you need to do is practice. Fourth rule, substitute values. So far, we've been looking at letters as a way of presenting things we do not know or are not sure of. They can also be used as a placeholder for values that will change, like in a formula. So if I give you something like, to find the area of a rectangle, we would use the formula that area equals LB, which is length times breadth. Now, that'll change for all sorts of triangles, or rectangles. Triangles. Told you it was hard. So, if we had a rectangle that measures 12 by 4, you would substitute the length to be 12, the breadth to be 4, and LB just means you multiply them together. So LB would be 12 times 4, which would be 48. You might have another rectangle where the length was 8 and the breadth was 8. You substitute the 8 and the 8 in, and you'd get 64, etc. So they would change. So all you're really going to do is substitute the letter and just replace it with a number in all these cases. And I'll tell you the way I usually deal with this. So in the following questions, we're going to use the values that t is equal to 3, u is minus 2, v is 4, and w is minus 4. So if we have something like 3uv, we replace the u and the v with the appropriate values as above, remembering that 3uv means 3 multiplied by u multiplied by v. So I generally put, when I've got a letter and I'm replacing it, I put it in brackets so that I don't lose sight of what the sign is around it. And a 3 times the minus 2, which is u, and the v, which is 4. If I do that one stage, 3 times minus 2 gives me a 6. The plus and the minus gives me a minus. So we get minus 6. I've still to multiply that by 4. And I would get minus 24 from that because of a plus and a minus in the minus 6 and the plus 4. To do another example. Following question, use the values. It's the same example. What about the following? 2vw minus 2uv. Okay. We have to use the rules of BIDMAS to solve, and again, that's in the directed number quick flip if you need me to go over it again. Or you need to go over it again. So you would do your multiplication before your subtraction. So you do 2 times v times w. V is 4, w is minus 4. And that minus sign should be, that's just indicating that that's the next line. Minus 3 times minus 2 times minus 4, because that's what t, u, and v are. 3, u is minus 2, v is 4. And if I do those out, I'll have 2 times 4 is 8. 8 times minus 4 is minus 32. I'll have minus 3 times minus 2, which is minus 6. Minus 6 times 4 is minus 24. I'm going to have minus 32 minus minus 24. Your minus minus becomes a plus. So you'll have minus 32 plus 24, which would give you minus 8. Confused? I hope so. Because there's no point me putting the easy ones in here. If you're looking back in your notes later or looking through this video later, you don't want video for or examples of ones that you already know how to do, if you know what I mean. We'll have all the examples in your notes as well. That's about as hard as it can kind of get with simple add and subtracting. They can make it slightly harder by putting square terms, etc. in, but we'll have those practiced and we'll go through them. Let's put it all together, see what we get. We use all these rules to solve equations and find unknowns. Remember, the object of all these problems is that we want to end up with the unknown value equals or x equals, something like that. We're going to get the letter equals everything else. Okay? And I'm saying remember because that's from last year. So for solving equations, if we had the problem x plus 3 equals 7, right? Some people can find that letter being there off-putting, but you've been doing these examples for years. If the question was just a box plus 3 equals 7, you'd have no hesitating in 7 form because you would ask yourself, what plus 3 equals 7? And for an awful lot of questions in algebra, you can just ask yourself that question and say, what plus the number equals the other number? And you'll be able to reason it out. However, I would like you to get in the way of using the following method to solve these questions. Move the numbers away from the unknown one step at a time until you're left with just x equals or whatever the letter is. When something crosses over the equal sign, it does the opposite of what it was doing beforehand. Right? Those are the two steps that you really want to think of. So if I think what's the opposite of adding, the opposite of adding is subtracting. Similarly, the opposite of subtracting is adding. And if I say what's the opposite of multiplying, the opposite of multiplying is dividing. The opposite of dividing is multiplying. So if I have x plus 3 equals 7, I'm going to move the 3 to the opposite side. So I'm going to take this plus 3 and I'm going to move it over there. Now sometimes it helps if you draw the circle around the plus 3 or the thing you're going to move and show the action of what you're doing. So draw the arrow over the other side. I would write everything down exactly straight underneath where it was, and the only thing different is going to be your new number that you're moving across. Your plus 3, or you're adding 3, move to the other side becomes a take away 3. And the x and the 7 stay exactly the same. So you've got x equals 7 minus 3. If we tidy that up, we'll just get x equals 4, which is exactly what you expected. Okay. And we'll practice tons and tons of those, but they don't generally come up an awful lot. The type that come up usually are two-step equations. These questions are still quite simple, but can get harder by introducing the following complications. So if 3x minus 5 equals 16, we're going to start off by moving the minus 5 to the other side. The opposite of taking away 5 is to add 5. We write everything else down exactly as it was and add it on. And if 3x equals 16 plus 5, 3x, tidying that bit up on the right, gives us 21. This 3x means 3 multiplied by x. And the opposite of multiplied by 3 is dividing by 3. So 21 divided by 3 gives me 7. And that would be your answer. Now you can check all these by putting it back into your equation. You can put x into your equation. So think about it. 3 times 7 is 21. If I do 21 take away 5 gives me 16. If that works, you've done the equation right. If you don't get it, you can go back through it. I nearly think scribble it out, take a new page, and see what you come up with. There's a couple for you to try for yourself. I'm going to stick some homework and stuff down below, but those are the ones you can try. Now for hard here, they get a wee bit more complicated again by introducing unknowns both sides. And again, we did this in ICATS last year. I taught you at this level. Consider 4x plus 3 equals 2x plus 1. Remember, the objective is to get all the letter terms to one side so we get x equals and all the number terms of the other so we can simplify them. So again, I'm going to move one thing at a time. I'm going to move the plus 3 over to the other side first. Adding 3, the opposite of that is to take away 3, and I'll write everything else down exactly as it is there. I've got a 4x, I move the plus 3, I'm even going to leave myself a space. I've got an equals, I've got a 2x plus 1, and I've got a minus 3. I'm going to get the x term, the 2x, over the left hand side. The opposite of adding 2x is take away 2x. Write everything else down exactly as it was, plus 1 minus 3 still there. The plus 2x becomes a minus 2x. If I continue that on, we get 4x minus 2x equals plus 1 minus 3. If I simplify 4x minus 2x, I get 2x. And I do plus 1 minus 3 gives minus 2. Move the multiplied by 2 to the opposite side. So 2 multiplied by x, I'm going to move that 2 away. I would get minus 2 divided by 2, and that gives me minus 1. And again, you can substitute back in to check your answer. Quite a lot to take in, and I know I layered those all on top, but you're going to practice these like mad, like I say. And there's no point. You'll do them in stages in class, but if I do it in stages in class, you'll do them for about 20 minutes and stop. And you're going to achieve more than that in class on Tuesday. For those of you that are quite comfortable, as you rightly know, the more you practice algebra, the better you get. It's a bit like driving the car. When you're trying to learn how to drive the car, the best thing you can do is drive that car with somebody sitting beside you, so you get in the way of doing all those motions. And much like that, you're going to have somebody sitting beside you, more than likely in class, knows exactly what they're doing, even if you aren't 100% sure. There are examples down there to do them, bring them with you, put them in. I'll mark them as well. It's going to be a bit different in class on Tuesday as well, because I'm going to be freely available to teach you. Actually, put in the finer detail for you. Whereas in an awful lot of cases, you're heavily reliant on the videos because of those new topics. This algebra thing runs right throughout the course. Like, we used to solve an awful lot of bits. I'm going to spend an awful lot of time, like I say, on this. There's an awful lot of aspects on it with higher. We've got simultaneous equations, we've got quadratic equations, we've got surds and things that come off. They're quite algebra-like as well, although we'll probably do this much later. But there's quite an awful lot of algebra and forming expressions and things like that. The videos will probably be quite light for the foundation ones. Usually just keep on practicing, and I'll increase the difficulty ever so slightly all the time. The higher ones will get new videos every week, and you'll be able to rattle on with those. We'll increase the difficulty of them as much as we can to get you ready for it, because an awful lot of you are doing very, very well, and I want to give you every opportunity to do as best you can. So, loads of questions, I'm sure. Bring them with you to class, especially if it's your first time doing algebra or haven't done algebra in a very, very long time. You're going to be very rusty, you're going to be very confused. Bring it with you, and we'll see how you get on. Alright, catch you then. See you later. Bye.
My baby don't mess around because she loves me so, at least I know for sure. But does she really wanna, but can't stand to see me walk out the door? I can't stand to fight the feeling, cause the thought alone is killing me right now. Thank God for Mom and Dad for sticking two together, cause we don't know how. Hey, yeah. Hey, yeah. Hey, yeah. Hey, yeah. You think you got it, oh, you think you got it, but got it, just don't get it till there's nothing at all. We get together, oh, we get together, but separate's always better when there's feelings involved. If what they say that nothing is forever, what makes love the exceptions? Why, oh, why, oh, why, oh, why, oh, why are we so in denial when we know we're not happy here? Hey, yeah. 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 You're alright now, fellas. Oh, what's cooler than being cool? I can't hear you, oh no. I say what's cooler than being cool. And alright, alright, alright. Alright, 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 alright. Alright now, ladies, we're gonna break it down in just a few seconds here. Don't make me break it down for nothing. I wanna see you all on your all's baddest behavior. I say, lend me some sugar, I am your neighbor. Shake, 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 shake it like a Polaroid. Shake, 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 shake it like a Polaroid picture now. But shake it, oh no, but shake it, shake, shake, shake it, shake it, shake it, shake, shake, shake it like a Polaroid picture now. But shake it, I say, shake it, shake, shake, shake it, shake it, oh no, and shake it up and shake it up and hey, yeah. And